Hi, and welcome to our math. Today I'm doing a series of videos on functions, and in this video I am just finding the domain of some functions. So for the first two, notice they're both radicals, square roots. There's another one down here. I might skip to that one. Maybe I should have clustered them together originally. The thing is, if you have an even root, so if you have the n root of a radical and n is even, then a has to be greater than or equal to 0. So that's the basic rule. So for this first one, for my domain, x has to be greater than or equal to 0, or in interval notation, we go from 0 to infinity. For the second one, we just take 4x minus 11 is greater than or equal to 0. 4x is greater than or equal to 11, divide by 4. It's positive, so we don't flip that inequality sign. So the domain is x is greater than or equal to 11 fourths. Or we could say that the domain is 11 fourths to infinity. To continue with the basic rule, if n is odd, then the domain is all real. What? Because if it's even, the graph looks like this, or it looks like this, or it looks like this, or it looks like this, depending on the positives and negatives. That's a whole other video. But that's the 4 options for an even. If it's odd, the graph looks like this, or it looks like this. Either way, notice it's going from negative infinity to positive infinity, and that right there is your domain, that left to right being infinite. So the domain, when it's odd, is negative infinity to positive infinity. Or you could write negative infinity is less than x is less than positive infinity if you want the inequality. Either way works, because if it's odd, the odd thing about an odd radical is it's oddly simple. You can ignore whatever is inside. But the even ones are picky and obnoxious. Okay, so then what about a line? Lines, in 9 cases out of 10, the domain is all real. Negative infinity to positive infinity. Or negative infinity is less than x is less than positive infinity. Lines are kind of, or any polynomial is the basic building block of math. So for a line, it goes from negative infinity to positive infinity. The only line that doesn't, so our horizontal works too. The only one that doesn't is the vertical. Vertical. But this one is not a function. And so the domain, so whatever this is, x equals number, so x equals a, the domain is just going to be x equals a. That, I should probably get all that on the camera. That's all it is. The vertical is the only one. It's not a function. The domain is just the value of whatever it equals. Everything else, all other lines, the domain is going to be all real. Easy peasy. All right, so let's come back up here. The next one we have, oh, there's our horizontal line. You can tell there's no x's, so this is our horizontal line. So the domain is going to be that negative infinity to positive infinity. This is a cubic. The basic graph of this looks like this. So the domain here is also going to be all real. The only time it isn't all real is when there is a restriction. And in reality, the only times there are restrictions in a basic algebra class is under an even radical, which we just talked about, a rational, that's like 1 over x, which we're about to talk about, and the third one is a log, which isn't on my list, but like log of x. And for that one, that argument has to be greater than 0. This one, x cannot equal 0. So I already talked about the radical, where the argument has to be greater than or equal to 0. You can't have a 0 in the denominator of a fraction. And with a log, which we're not talking about here, the argument has to be greater than 0. Those are the 3 basic domain restrictions. Outside of that, you're really not going to get many. Outside of that, pretty much everything else, if you're not in an application problem, is going to be all real. So from what I just told you with our basic restrictions, here the domain is x cannot be 0, or, this is lovely, to 0 joined with 0 to positive infinity. This one, neither of our denominators can be 0. So 2x minus 7 can't be 0, so 2x cannot be 7. So the domain x cannot be 7 halves, because we have to divide by 2, or 0. If you want the interval notation, it gets really long. Negative infinity to 0, joined with 0 to 7 halves, joined with 7 halves to positive infinity. And if you can get all of that together, you have this one. You just have holes at any 0 in the denominator. So this becomes your rational. So rational says no 0 in the denominator. Radical says no negative under the radical, even radical. Odds, we don't care. And log is no 0 in the argument. But this is it for your restrictions. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I will see you on the next video. Thanks.